It is interesting to see the relation between the kinetic energy and the potential energy as a function of time and as a function of position. Since the total energy is a constant, okay, the total energy is a constant, so we must have the relation between the kinetic energy and the potential energy, that is, these two terms, the summation of these two terms must be a constant. Okay, and since we know that the kinetic energy, this term, depend on the cos square function, okay, and the potential energy depend on the sine square function. So we know that the value of the kinetic energy and potential energy will oscillate between the minimum value to the maximum value. And if we look at this figure, you can see that the kinetic energy, which is the blue line, oscillate from 0 to the maximum value of 1/2 of Ka square, right, as a sinusoidal function. And also the potential energy oscillate from this maximum value 1/Ka square to the 0. And when the kinetic energy increase, the potential energy decrease, to make the summation of these two terms, U and K, to be a constant. Okay, and when the kinetic energy reach the maximum value, the potential energy reach the minimum value, which is 0, and then it's reversed. That is, the kinetic energy go down and the potential energy go up. Okay. This is a variation of the kinetic energy and potential energy in time. We can also have the similar relation if we look at the kinetic energy, the blue line, and the potential energy, the brown line, as a function of the position. We have that this line is a potential energy as a function of the position. It has a maximum value when the displacement of the object is equal to the amplitude, or the minus of the amplitude. Okay, and it goes down as a parabola. Now the curve is a parabola because if you look at this term, this is a quadratic term, which the graph is a parabola. And when the kinetic, the potential energy go down like this, the kinetic energy go up to make the summation equal to a constant. So when the potential energy reaches the minimum value at 0, the kinetic energy will reach the maximum value at the 1/2 of Ka square, and it's reverse direction. The kinetic energy go down and the potential energy go up. You can see that it is interesting that the kinetic energy is equal to 0 when x is equal to a or minus a. This is because a is the maximum value of the displacement, and it means that at the maximum value of the displacement, the velocity must be 0 here. Alright. 0 here. So the kinetic energy is 0 at this point. Okay. And also at this point the kinetic energy is maximum. This is when the kinetic energy is maximum, it means that the velocity is maximum also, right? And the potential energy is minimum. You can see that at the minimum value of the potential energy x is equal to 0, which is the equilibrium point. Okay. So at the equilibrium point, you know that you can see that the velocity is maximum at the equilibrium point. Here at this point. Okay. And potential energy is 0 because h is 0 here.